Okay, this is problem number 13. A problem about some people getting on a bus and then they're going to go somewhere. Apparently it costs some money. So, what I know initially anyway is that uh, it's going to be $160 to charter the bus. And if all of them were there, that would be the people that went on the trip plus the 8 people that decided at the last moment that they were sick and decided to miss the trip. So what we have here then is that the amount per person would be $160 divided by whatever X is, that's the number of people who went on the trip, by, plus 8. Um, Now I know that the amount per person would be $1 more, so the amount per person plus $1. And keep in mind here that this amount per person, this is the same as the amount up here. So like if this was $10, this would be $11. Um, that's going to be what they pay if just X people go on the trip instead of X plus 8. So I've got those two equations. What I can do is subtract 1 from both sides of the second equation, and then the left-hand side of each of the equations are identical. It's both amount per person. So I can set an equation here that basically says, I've got this, let me highlight some things here. This amount right here is equal to, that's a good color, this amount right there. So I'm just equating those two values because they're both equal to amount per person. That's a lot of highlighting. I'll have to get rid of all of that. Not very clean. So let's try and solve that equation. First thing I notice is the right-hand side of that equation has 2 terms, so I'm going to try and put them together and make 1 term. So I change 1 into a different clever form of 1, x divided by x. Now I have common denominators on the right-hand side of the equation between the 2 terms. So I can put them together. This is a pretty standard proportion, so lots of different ways of isolating the values of x, but essentially you're trying to turn the 2 fractions into something that's not fractions. So I wind up with 160x is equal to 2 quantities multiplied together. From there I can just expand the right-hand side of that equation. I notice that there's 160x on both sides of the equation, so I can see right away that those terms are going to cancel. I'm left with some extra stuff on the right-hand side of the equation. I'm not a big fan of the coefficient of negative in front of negative coefficient in front of the quadratic term, so I added all 3 of these terms to the left-hand side of the equation, or really to both sides of the equation. Alternatively, I could have just multiplied everything by -1. That would have worked too. But now I've got a factorable quadratic equation. So that factors nicely. 40 multiplied by -32 is -1,280. You have your times tables memorized up to 40, don't you? I don't either. I just tried some things. So basically what I know then is that this original equation, after a little bit of work, so this arrow represents a ton of algebraic work, I can turn it into this factored form that is pretty easy to see that x is -40 or x is 32. I'm using the zero product property there. And remember that x, these x's that I have up here, those are the number of people who went on the trip. I'll pause and let that sink in, and then point out that what that means is 32 elderly citizens went on the trip. Or you could say -40 elderly citizens went on the trip, but either way, I think 32 is the realistic number there. If you try and figure out the amount per person, 160 divided by 40 would be $4 per person. And then 160 divided by 32 would be $4 plus $1, or $5 per person altogether. So it fits the story. I don't know where they're going for $4 or in this case now $5. And if the 32 people are angry, I'm not quite sure, but um, I know 32 elderly citizens went on the trip. Hope that helped. I will see you in class on Monday.